we started this problem and I'm going to rewrite the equation we have. And we solve these by graphing, which reminds me, if you don't already, grab your calculator. If you don't already have it, grab your calculator. So as I mentioned last class, we're going to do this one all three ways. We did two of them last class. And then moving forward, you'll have the choice of how you want to solve this. So we solve this one by graphing. We solve this one by substitution. We're going to solve this one by elimination now, and then move on to some others. So to solve this by elimination, we have to decide first which one we want to get rid of, L or S. Which one would you guys like to get rid of first? L, okay. So if we were to get rid of L first, these both need to be the same. That means I would need to multiply this equation by 5. Okay. And then, because we're trying to get rid of our L's and both are positive, we can subtract the equation. So when I subtract these, 5L minus 5L gives me 0. 3 minus 5 gives me negative 2x. 220 minus 300 gives me negative 80. As I mentioned last class, be careful with your negatives because these word problems you should not end up with negative numbers. So if you did, there's something wrong there. I can divide both of these by negative 2. And get my answer for S. And then I can put this back in and find my answer for L. So you have different options. You can put it back into one of the originals or the one you changed it to. It doesn't matter which one. Again, we knew those answers already because we had already solved it twice. So those numbers shouldn't be surprising, but they should be the same as how we solved them before. If you like one method better than the others, go with that. If you want to mix it up and do one word problem by graphing, one by substitution, one by elimination, go with that. It's really your preference. As long as you solve it correctly, you should get the same answer no matter how you solve it. Questions on that one? We're going to do the example on the next page. Just as before, take a second, read through this, and then we'll figure out what's important, what's not. What did you find that was important here? Swing acts are 5 minutes long. What else is important here?
Quantity acts are 3 minutes long.
Yes. Anything else?
Because
12 acts lasted 50 minutes. Anything else?
seasonal.
So they give us variables, that's important. Number of honey acts. Number of honey acts. And what are we looking for? Okay. So in this example, we're looking for both. So first things first, they define our variables for us, so let's write those down. C is the number of how many acts? And S is the number of singing acts. When we define our variables, it has to be very specific. Number of something, cost of something. Usually it's just one of those two. And we need to write two equations. We're given 4 different numbers and 2 variables. The 12 acts and the 50 minutes are our total numbers. So we know our 2 equations are going to equal 12 and 50. So for 12, 12 is the total number of acts. How would I make that equation? C plus S. Because C and S are the number of acts. If 50 is the total number of minutes, we have to have the number of acts and their length. Pardon? C3 plus S5. I'm going to mix that around just a little bit. 3C. Do we want to solve this by graphing, substitution, or elimination? You guys choose. Substitution. If you want to solve it by something other than substitution, you go right for that. So for solving by substitution, that means we need a C equals or an S equals. Does not matter which one. Let's say I want to solve for C. I would take this equation because the variables are by itself and solve for C. So subtract S on both sides. Then I can put my equation I solved for C back into my second one, where C is. So when I rewrite that second equation, it'll look something like this. 3 times 12 minus S plus 5S equals 50. And I can solve for S and then go back and solve for C. When you are solving by substitution or elimination, whichever one you solve for first or eliminate first, you're going to end up getting the answer to the other one first. So since I decided to solve for C, I'm going to find S first. If I were using elimination and I got rid of C, I would be solving for S first. So keep that in mind. Combine your left turn, so this would give us 36 plus 2x. And then I could solve for s. Subtract 36, divide by 2. Then it like make my s's bigger so they don't look like 5s. What is that, 14? And then once we find S, we can go back and find C. Put it in whichever equation you want. In this case, since we solved for C, I'm going to put it back into the C equation. So this would give us 5 harmony acts and 7 singing acts. Questions on that one? For sake of time, I want to get to some specific examples. So somewhere in that packet, you have a bunch of examples, so you can go through a bunch of different problems. But find this page, the one that talks about flying, the one down a river. picture of the maze. For these examples, I'm going to read this out loud. For number 1, flying with the wind, a plane went 369 miles per hour. Flying into the same wind, the plane only went 325 miles per hour. Find the speed of the plane in still air and the speed of the wind. So important things we have: when the plane was flying with the wind, it went 369 miles per hour. When it was flying into the wind, it went 325 miles per hour. And we're looking for the speed of the plane in still air, so with no wind, and the speed of the wind. Whatever it tells you to find when it does not give you variables are going to be your variables. So the two things we don't know are the speed of the plane and the wind speed. So that's what we're going to define our variables as. You can say P and W, X and Y. It does not matter what your variables are. And we know these two totals, 369 and 325. If this is flying with, if the plane is flying with the wind, that means the wind is kind of helping it. So whatever the plane speed is and the wind speed is making it go faster. So we're going to add those two together. We don't know what those two are, but we can add P and W, whatever that is, would give us 369. And then when it says flying into the same wind, that's basically the opposite. It's no longer flying with the wind, it's going against it. So now it doesn't have that wind to push it. It's being subtracted, you could think. So we're going to take the plane speed and subtract the wind speed, and it would give us that 325. These are good elimination problems, but that doesn't mean you can't solve it by substitution or graphing. So we have our variables, we have our equations. Let's solve this by elimination. Does not matter if we get rid of P or W first. I'm going to get rid of W just because we have a positive and a negative here, so I can add the two equations together. Remember, positive and negative coefficient, add the equations for elimination. Two positive coefficients or two negative coefficients, subtract. So P plus P would give me 2P. The W's would cancel. Someone tell me what 369 and 325 is. 94. Okay. And then divide both sides by 2. your units here, it is miles per hour. When, after we find the W, let's say you put the wrong thing somehow, got these incorrectly, realistically, a plane should move faster than wind unless there's some crazy thing happening like a hurricane or a tornado or something like that. So if your wind speed is going faster than your plane speed, something's wrong there. Because we're hoping these are normal situations. Okay. You can put 347 back into either of these equations and find W. When you're doing this work, if you're not doing this by graphing, do me a favor and like dots in your answers or circle them something so that I know these are your final answers. Because it could get lost in your work somewhere. So flying with the wind, add. Into the wind, you're going against the wind, so subtract. Do we have questions on that one? We're going to do this next example where it's talking about a boat. Going down the river, a boat went 13 kilometers per hour. Going up the river, it only went 3 kilometers per hour. What is the speed of the current? So it's talking about the river. How fast would the boat go if there were no current? So just as before, important information. Down the river, the boat went 13. Up the river, it only went 3. So that would be like going against. We need to know the speed of the current or the speed of the river. And then the speed of the boat. So then what two things do we need to find or don't we know? The current or the current speed. And then how fast the boat would go, that's like the boat speed. So those could be your two variables. You can say S and B, X and Y, whatever two variables you want. C and D, it doesn't matter. I'm going to say C and D. So when I say current speed, I'm not talking about like actual speed right now. I'm talking about the river. If you need to put in parentheses, river. Anyone want to take a guess as to how we would write these equations? super close. It'd be B minus C. So let's. Nothing matters for the first one, but. I'm going to solve this one, excuse me, by graphing. This is one, since the numbers are small enough, you could actually graph by hand, but we're just going to use the calculator. As I mentioned before, when you graph this in your calculator, these need to be in first variable x and y. If you weren't using those, kind of change them and make them consistent. I want B to be my x, C to be my y. And then you need to convert both of these to the in slope intercept form. Take a second, do that. You have y equals negative x plus 13 and y equals x minus 3. In your calculator, go into your y equals. Did not open this, if I should have. And you're going to put those two equations in your y equals. Negative x plus 13, x minus 3. It's nicer on Desmos, so if you're practicing this at home over the weekend and you're using Desmos, put the two in. You don't really have to convert them, but they do need to have variables x and y or a volt graph. But if you put them in as is, but change the variables to x and y, you can easily go graph, and then you can click on the intersection point. The calculator's a little different. So here, after you put these in here, go in and graph it. You should be able to see where they intersect. And you could count it, but you may not have your grid lines on. So to be as accurate as possible, to make sure that is indeed the point, you could have your calculator figure out what that intersection point is. So if you go into second in their trace, your calculate menu, you're looking for where they intersect, so number 5. It'll ask you for the first curve, that's just one of the lines, as long as, I don't know how much it is. I'm assuming it's somewhere off this thing. You shouldn't need to see it, but just in case, I moved mine just so we could see it. It's on one of the lines. I can hit enter. I see my cursor is on the second line. I can hit enter. It'll ask me to guess that if you want to pinpoint where it is. You don't. You want the calculator to do the work. Hit enter again, and it'll tell you what that is. So x is 8, y is 5. And then you would just need to change those back to whatever variables you had if those were not originally x and y. So 8 was x, which was b. And 5 was y, which was c. So if you were doing it in your calculator, that's about as much work as I would need to see. If you converted them both into slope-intercept form, you found the order pair, and then you converted that order pair into your answers with units. But I would need to know that you know which is which. Do we have any questions on that one? To quickly recap, if you're dealing with planes and speed, with the wind is plus, into the wind is minus. If you're dealing with boats, down the river is plus, even though that sounds opposite. Up the river is minus, you're going against it. Most of these have that same wording. With the current would be plus, against, minus. The other one you might see is with the tailwind, and then into the same wind. With the tailwind means basically the wind is pushing you from behind, so you're adding the wind and the plane speed. And then into the same wind, the plane is going against. So it would be minus. On Monday, you're going to take our 3.1, which is systems of mapping, and 3.4, which is systems of word problems quiz. To mean Tuesday we're going to go over it, and Wednesday is going to be your test on those two sections. Thursday we're going to take our quiz on substitution and elimination. To mean Friday we're going to go over it. And then the following Monday, I will be here. Some of you may not be here, and that's fine. But if you are here, the syllabus is going to pass out your tests on substitution and elimination that following Monday. And then you'll have a chance to finish it Tuesday. So as you guys go into the weekend, start preparing for your quizzes/tests. Do your academies, do your delta math, go back and do additional practice in the notes that you maybe didn't do. For the remainder class, you have plenty of practice problems in those notes on systems of equations, word problems, as well as one academy, which I don't think I wrote up there, but is due today for systems of equations word problems. And then the delta math on that is due on Monday. We have plenty of things to be practicing and working through. I'll be walking around if you have any questions. Anyone have any questions on what we're doing for the rest of class? Yes. Oh. You guys have this time to work